So this video is about doing trigonometry from any angle, but these would be some special cases. What if the angle falls on one of the axes, like so it falls directly on the positive y-axis or the negative x-axis, okay? So this would be an example of that. Let's say I have cosine of 3 pi over 2, all right? So if I were to, again, pull out my coordinate axis, 3 pi over 2, if it's a denominator of 2, that means I'm going in 90-degree increments. Okay, so that means I would go 1, 2, 3. So my angle's going to go, or my line stops here. Okay, so I can't make a triangle, right? So if a triangle can't be made, you just kind of think about it this way. Notice how, again, the green line that I've made with the arrow going down, is there any x value? If something is going straight up and down, is it going right or left? The answer is no. So that would mean the x value is 0. Okay. Now let's talk about the y value. So obviously it's going downwards, correct? So again, it could be any number, but I'm going to say it's -1, right? So it's no big deal. So -1 would be my answer, because it's going down, that's why it's negative. Why is it the value of 1? Well, it could be any number. You can make it 7, you can make it 10, it doesn't matter. But 1 is obviously the easiest. Okay. Now you might be saying, well, cosine, don't we need like adjacent hypotenuse, something like that? Okay. Well, let me go back and give you an example here. So, like in this triangle, notice how if I'm doing cosine, cosine happened to be the x value over the hypotenuse. Look at this triangle. If I did tangent, again, it's opposite over adjacent, or y, the y value over the x value, 1 over radical 3, which we rationalized. Sine, take a look at this. Again, sine from the reference angle is always going to be the opposite, which is the y value. Okay, so here's what I'm trying to help you discover. Okay, if it's cosine, it's always going to be x over r, meaning the x value over the radius value. Okay, which, again, the radius is always going to be a +1. Okay, so because just go ahead and accept that, like in a circle, right? I can't have a negative radius because as I'm rotating around a circle, my radius will always be a positive value. Okay, so x in this case was 0 over 1, which would just equal 0. Okay, so cosine is the x value over the radius, which will always be 1. All right, unless it's told otherwise. Okay, so let's do another example here. Let's do cosine of 7 pi. Nope, let's do 8 pi over 4. 8 pi over 4. Now, normally, like, oh, denominator of 4, does that mean 45-degree increments? Technically, yes. You could go ahead and graph this with 45-degree increments, but think about it. Can I reduce 8 over 4? Well, yeah, I can. 4 goes in the both, so wouldn't that be cosine 2 pi? And if you know your radians well enough, you would know that as I go around the circle, again, it lands up right there, back to where we started, all 1 full rotation, 2 pi. So now, again, I can't make a triangle, but I do need to identify the x value and the y value. So this time, see how the radius or the line is going straight to the right. Is it going up or down? No. So if it's not going up or down, the y value is going to be 0, right? Because the line's just going straight to the right. And if it's going right, that means it's positive, right? Because if something goes to the right, it's positive. If it's left, it's negative. So again, you can give it any value, but I'll make it a +1. Okay? And r is always going to be +1, unless otherwise stated. So, remember, we just talked about a cosine is going to be the x value over r. So in this case, it's going to be 1 over 1, which equals 1. Okay? So, that is, if it ends up on the fault line there, let's do an example with sine here. So let's say if I did sine, let's do 12 pi over 4. 12 pi over 4. So same scenario, just like the last problem. Oh, it's over 4, that means 45-degree increments. But always look if I can reduce 12 over 4. Is this simply 3 pi? Okay. That's a sia. Whoops. Lol. So sine of 3 pi. So if I were to graph this, so all the way around is 2 pi, so 3 pi would be right here. So it would end up like this. Okay, so x value is going to the left, so it does have a value, and if it's going left, it's -1. Y value is not going up or down at all, so the y value is 0, and r is always +1. So for sine, it's always going to be the y value over the radius, which in this case is 0 over 1, which is equal to 0. Okay. All right. Finally, let's go ahead and talk about tangents. So tangent will be tricky in some spots. So let's try tangent pi over 2. Okay, tangent pi over 2. So if I were to make my graph here, pi over 2 is 90 degrees, so my angle ends up just right there. Okay. So if it's going straight up in the air, that means it has no x value, so 0. Y, it's going up, so positive, and then r is positive. Okay, so tangent, I think I did an example problem here. Let me scroll back real quick, see if there we go. So tangent is opposite over adjacent, or the y value over the x value. So notice how, for my reference angle, opposite over adjacent, y value over x value. Let's go back. Okay. So y value over x value. In this case, so if it's y over x, wouldn't that be 1 over 0? Uh-oh. Now some of you guys say, oh, it's just 0, right? No, if it's the 0's in the denominator, that actually means this is undefined. Now, some of you might be asking, well, what does that mean? Undefined, how can that possibly be? Well, we haven't gone over graphing a tangent function yet. Like, what does a graph look like? We've graphed the angle and found tangent of an angle, but what does the actual tangent function look like? So we'll talk about that a little bit later. But for now, it is undefined because the 0 is in the denominator. We'll do one more for tangent, and then we'll go ahead and end this one. Let's do tangent of 5 pi. Okay, tangent of 5 pi. So, again, if I were to graph this, one way around is 2 pi, another way around is 4 pi. So 5 pi would end up over here. Okay. So if it's 5 pi, again, it's going straight to the left, so it has x value, and it's negative if it's going left, so we'll say -1. Since it's not going up or down, the y value is 0, and r is 0. Okay. All right, and as we just talked about, tangent is y over x, so it would be 0 over 1, which is just simply 0. So see the difference in this one, if 1 over 0, if 0 is in the denominator, it's undefined. Or as I'd say, if 0 is under the line, it's undefined. Under the line, undefined. And then if it's above the line, I have to say it with an accent. If it's above the line, it's just simply 0. Okay. So that is how you would graph, or how you would find the answer of trig with any angle if it happens to fall on one of the axes.